Okay, and the mental math could just simply be a game that you start your class with, or after the cumulative review, it could just be a game. You could be teaching them explicitly a strategy, because they will not just know how to do, say you're teaching multiplication, you want to do take away a group, so that if they know 3 times 4, they can know 3 times 5. You know, you actually have to show them. So it could be that. It could be just taking some risks and trying some crazy stuff with fluency and playing some games. And you're working at is improving that accuracy and getting them a little more fluent. Okay, so fluent means they're doing it quickly and almost effortlessly. So we want to free up the thinking space with those activities by then if they don't get weighted down on what is 12 plus 2. Okay, we want them to know that that's 14, and if they don't, how can they get there? And that will free them up for their thinking. And this is where you're going to build that those foundational facts as well. And then we all have a really good understanding of number talks from our last PD. They also build that fluency. They build community in your classroom, okay, which is so important, and that support, the support that they can offer each other. And the ability to take a risk. Like, isn't that awesome that when you're doing a number talk, if a kid makes a mistake, you all just keep going? Like, I think that's such a beautiful thing. I love that. And you're building that number sense or that common sense through these two things as well. Both of them should be fun. Your classroom should be fun in math. And I think that's something that sometimes, especially if we are not loving math, we sometimes get caught up in just sitting there and doing work, but you really want to include something fun every day. Like, as much as you teach 7 and 8s, you know how their attitudes are. They cannot be the best sometimes. Kids would literally like come into class happy. Kids that I would be like, oh, you know, they're not maybe necessarily in a good place, and those hormones are raging, and they're 13-year-olds, and they would come happy because they knew we were going to play with numbers at some point that day. We were going to have fun at some point. So try to include just something, even just like a 2-minute, something that's fun every day if you can, especially every grade, but those middle years, they need it. And those number talks, they teach that flexibility, and how beautiful that you might not have a strategy to answer that question, but your partner standing beside you might have one, and now all of a sudden you've got some way to figure that
out. One thing that we find is tricky in the world of intervention is the mental math intervention. So math intervention can be tricky in and of itself, but it really gets messy when we see a little one or a big one of any age who is struggling with the whole mental math concept. And I'll loop back to the idea of working memory, because working memory is so highly impacted. And when it comes to intervening with mental math, this is the chicken and the egg often. We don't know which one came first. Did the anxiety come first, or is the working memory the hiccup? And it's very difficult to dive and dig through that. We often are asked, for assessments to filter that out. We find that you have to kind of work through it before the assessment, like the psychologist assessment, really digs deeper. So if you could imagine working memory is your brain's ability to juggle multiple things at a time. So short-term and long-term memory is what do you hold? For me, short-term memory is what do I hold right here. Long-term memory is what can I tuck in my pockets, okay? Working memory is what happens when you have all those extra pieces and you're trying to juggle and do something with them. So when we look at mental math, there's a lot of things to juggle. We need knowledge of facts. Now be careful, I am not saying they need to just know their facts. They need to have the conceptual understanding of those facts. They need to know that when they see 4 times 7, what it means, 4 groups of 7, 7 groups of 4, an array, a picture, a connection to real world, things like that. Without the conceptual understanding, it's just a memorized fact, and that's a very, very thin place to build knowledge on. We need to have the ability to calculate mentally. Now, we all have met that person who calculates mentally on a little visual. You can see them. Actually, some of mine will actually lift their finger, and you can see them carry the 1. That's not mental calculation. That's pencil and paper calculation in the air. Okay? Right? And we've seen it, right? Or my favorite is the kindergartens who their tongue will, you say don't use your fingers, so their tongue will carry the 1. Right? You can see it happening. You can see the thinking. When Hattie talks about visible learning, that's visible learning. And then they have to have flexible reasoning. More than one way to arrive at a solution. So what does it look like when something's falling apart. Well, here's the things, as Marion says, here are the questions we would ask and what we would see. The first thing is if they have a weak conceptual understanding, usually the teachers will tell us, well, they have it one day and then it's gone the next. Okay, that means it's actually not a concept they understand. They held on to it, but they didn't keep it in their pocket. They may have a limited strategy, maybe even down to just one strategy to come to a solution. And they may not be consistently accurate. So, you know, I always think of the multiplication, the kid who is going to draw it out every time, no matter how big the number. You know, so it worked for 4 times 7. What about 40 times 72? They're drawing on their page. You can't find their answer because the page is all mucked up. Well, that tells me that the concept is probably not really strong if they have to rely on that. And it's an inefficient strategy for that question. And then we see those kids that are going through the motions, right? They're going through the motions, but they're not connecting it to yesterday's work or the next concept, or, oh yeah, we did something like this, or that reminds me of. And then, of course, there's always the behavioral symptoms, right? The task avoidance, off task, the grumbling, things like that. All of those are little hints that maybe the conceptual understanding is not at the place of where we're hoping the instruction to be. When we think of intervention, what we're trying to find is the point where they're only juggling one ball. Now, this is not short-term memory where you're holding it, you're actually tossing it up and down. We want to find the point of where in their learning are all the other ones tucked in their pockets. Those are the concepts they have mastered or at least proficient at. We don't want to give them so many that they're juggling a bunch at one time, just one little toss up and down. That's the point of entry we're looking for in intervention. We need to look at what is their conceptual understanding, fluency, and so on, and that's the skill we start at. Often, if the intervention we're providing doesn't seem to be sticking, I would be very inclined to believe that you've actually maybe given them a little too much. Back it up, back it up, back it up. You would be surprised sometimes how far you have to back it up to find the missing skill. And sometimes they have many of the skills, but it's one little piece that is missing. And you have to do a lot of investigating. So when we do find that point of entry, that one piece that we're going to juggle, we're going to use, very similar to we would with phonological awareness, we're going to use that progression of skills, but we need to be explicit and systematic. You have to be thinking about what is the best question to give this student to help them start, what is the next question that will get them going. This refers back to what we've all been talking about, is you have to go from the concrete, multisensory approach all the way to the pictorial or representational symbolic. Marion had a great image with the apple, right? So we go from concrete to semi-concrete, semi-abstract, abstract. You have to build them through. With our work with Kilpatrick, we use the same strategy, multisensory approach until they have it at a concept knowledge stage. Then we work to fluency or automaticity. So whenever we talk about basic facts, there's the elephant in the room. What about memorizing facts? Kids just need to know their facts. I won't disagree with you there. Kids need to know their facts, but memorizing facts is not effective. What happens for kids that memorize facts is they have too many facts to memorize because every fact becomes an individual piece of knowledge they have to hold on to. So 2 times 3 has to be held on to as separate from 3 times 2. So memorization really doesn't build conceptual knowledge and doesn't transfer. That's why those kids stick to those inefficient strategies, because they're memorizing something. When we look at mastery of facts, we think about automaticity, that they can recall it within about 3 seconds. Now, which ones should we be able to do that? Well, we don't want inefficient means, sorry. Passive storage, which is memorization, just doesn't get them very far and gets a lot of frustration on their part because there's lots of points where those little connections get mislabeled, right? 2 times 3 gets mixed up with 2 plus 3, things like that. So what we want is rapid recall, but rapid recall from a point of conceptual understanding, not memorization, okay? Because they have repeated experiences with strategies and reasoning. So drill and practice, or drill and kill, is appropriate only and very occasionally when students are effectively using those reasoning strategies. That's building automaticity. But you can't do that, as I keep saying, if you don't understand what you're building. Okay? Now, ever so often, you're going to find a student, sorry, and I keep standing, that requires a hook. So here's an example of a student. This isn't, I've tried to put it in a picture. A student who, for some reason, stored 7 times 8 as 52, right? So she understood the concept. She could draw it. She could explain it. She could explain it in multiple ways. She could do arrays. She could do the whole gamut. But when she was trying to rapidly recall, 52 would come out. So we had to switch the hook for her. And so I used an old kind of connection to times tables the fun way. And how I noticed this, you'll wonder why am I using playing cards, is the kids were playing a game. 7 times 8, 52. And she would get so frustrated with herself because she knew it wasn't 52, but, right, she's trying to do it quickly. So whenever 7 times 8 would come out, I took her aside, and I would turn the 8 on the side. So the story that goes behind this is 7 is a bouncy guy. He only has 1 leg. Of course, if you only have 1 leg, you have to bounce everywhere, right? He loves to swim. So he bounces on his double trampoline up to the diving board, which is the 5, and into the swimming pool, right? Now, the 56 part, we just did that kind of virtually in the air. I just talked her through it. But then, the next time I noticed the kids playing that card game, she actually would take that 8, flip it on its side, and go, oh, 56. Then, or sometimes she would flip it around. If she got 8 times 7, she would move it around. There's the hook, 56. And she replaced that long-term memory. And eventually then she didn't flip them at all, right? So you can see the progression of learning. But would I use that for kids who don't have an idea of what multiplication is? Never.
So, as Tammy was saying, we kind of go through 3 different steps when we're getting to fluency. So the first step in being able to figure out a fact is using something manipulative, like a manipulative in front of us, and counting. Okay, but we don't want to rely on that. It's not very efficient. Okay, it's not efficient at all, actually. We do not want to rely on that, but that is the first step. Okay, then the second thing we do when we're getting a little bit further along the fluency train is we're going to use reasoning to figure them out. So, for example, you might be using the double-double rule, the coffee rule for times 4. Okay, you take it times 2. If you know 2 times 2 is 4, then you double it. And you can do it for times 4, and then it's going to be 8. So you're going to be teaching them, but they have to stop and think, right? Still not super efficient, not an accurate recall right off the bat. But the more times we practice those things and we do those cool little tricks with the cards, and then she sees the water, again, think of it like a well-traveled highway in your brain. You're making a deeper path in your brain on that neuron to get to that fact. So more effective than the drill and kill, as we were mentioning, you know. And sometimes there's a place for that, especially when the kids just need to get faster, but they already have to have something to work with. Okay, so strategy is the key. These are the fun things, right? Just little things to help us remember. But the key is basically knowing the reasoning behind and why it works. Okay, so this is the second suggested resource. Okay, this one is full of games and rubrics and observations and all kinds of things that you can do with your kids to build fluency. This is one where we say fluency, the struggle is real, right? We talked about it when we talked about reading last year. Fluency, the struggle is real. In math, fluency, the struggle is also real. So this is your best friend to help get you there. So you'll want that one. Okay, so here's addition, which could also be subtraction. And these, again, are in this book. So when you're gifted this book by your principal, which I know we can count on them to do, you can take some time to look at this chapter. So the idea with fluency is you have to have a starting point. Okay, so don't even worry so much about all the arrows and all that junk up there. You have to have a starting point. If the kids don't even know 1, you're going to have a real hard time teaching a strategy. Okay, so you really want to get these sets in this first bracket solid before you start doing those more difficult facts. So you're going to make sure 0, 1, and 2 are solid. How do we do that? We count, and we count again, and we count forwards, and we count backwards, and we count the steps to the fish tank like the group had at the back there, counting, counting, counting. Okay, and then we're going to work on doubles. And it should be, we want to get those doubles automatic. And that's going to also help them when they're doing multiplication. You'll see that in the next slide. Then we're going to get those groups of 10 down and the 10, adding 10 or subtracting 10. Okay, once we kind of have a solid footing there, then we're going to go after those near doubles. So instead of 6 plus 6, 6 plus 7. Well, if you know 6 plus 6, just add one more. Oh, yeah. Okay, so, and then we're going to go into the making 10, combos of 10, and pretend a 10. So if I have 8 plus something, I can pretend that's 10 by adding 2, but then I have to take away 2 when I'm done. And some kids will hate that, and some will love it. It's okay if they hate it. They don't have to use it. It's just a strategy. Okay, so basically you're going to have a plan. Doesn't matter what the plan is, but it has to be strategic. Okay? And then similar for multiplication. Again, don't get caught up in the arrows or anything like that, but you have to have a starting point. 2s, 10s, and 5s are a really good starting point. Why? Because we count that by, right? We count by 2s. We count by 10s. We count by 5s. So they have some sort of foundation there to start with. So once you get those ones solid, we love 1s, right? They're going to be like, oh, check off the list. I got 1s down. 0s, again, no problem, right? You have 0 groups of anything, right? They're going to be like, oh yeah, that's 0. And then if you want to, you can introduce squares. You don't have to do it in this brand. You can move it to the bottom. But squares are fun because they're kind of like doubles, but kind of not. So that's a great question. How are squares like doubles and how are they not like doubles when we're adding and subtracting? Then you've got adding a group, subtracting a group. And again, don't sweat if you don't know what that is. There's videos for you to go through that. Breaking apart. So it's basically taking a bigger question and breaking it into like what we call friendly numbers, right? So that strategy, and again, there's a video to show you that. And the same with the near squares. So don't get caught up in all the arrows or anything like that. It's just can we go to the next slide? Thank you. It's just basically that you're going to have a plan and strategies involved. So again, here you can see, so here would be an example of a strategy. So I'm going to go after these ones, those ones. You could even do these flipped because this one really builds confidence, right? They're like, oh, I know all my 1s and 0s, I'm good. And then you're going to do the double-double and the 6 and the 8. And then, because once you get this and you know the double-double, you can do the double-double-double if you really wanted to. It's not going to be very efficient. But you can show them how they can use it to do it. And then 6, you can get a bunch of different ways. The kids find what one works for them. Subtracting a group, adding a group, break apart. Okay? So again, there's just 2 things to know about this and the foundational facts. So the first is purposeful. Don't just start at 1, then go to 2, then go to 3, then go to 4. Attack it with a purpose. Okay, so we're going to do this, then we're going to do this, and then we're going to do this. And why? Okay, so have a purpose. Don't just start in order and go through in order. And the second thing to know is that strategy has to be part of that picture. Okay, so again, don't get stressed out about all the arrows or anything that. You can't really mess it up, but you have to have something to work with. So strategy and purposeful. Okay, I promise it will make a difference. Okay, so as Tammy mentioned, there's that time test. They really don't help, and they don't actually tell you if the kids are fluent or not. You're going to learn who has math anxiety real quick, though. That might be one way to figure it out. Wouldn't be a very kind way to figure it out, but you would know right away who's going to freak out if you say, okay, got 20 questions, you got 30 seconds, go. You know, I would probably faint as a kid at that point, but you can really cause anxiety. So use anything timed. However, with that being said, sometimes when you're timing games, it's not as stressful. So you kind of have to gauge. You guys know your kids better than anybody else, so you can gauge it. Sometimes the timed games can actually be quite fun. But the key is, again, and I think that's where the second one comes in, the kids need lots of practice, and it has to be enjoyable. Okay, so then how do you assess it? Because, right, like, what else do we do to assess this stuff then? Because that 5-minute time test, that tells me everything if they know those fluency. Well, you're going to do a lot of observations, and you're going to talk to your kids. And again, there's a lot of supports for this in that book that you're going to be getting called Math Fluency. So you can literally do a 10-second interview with a student. I know that sounds ridiculous, but you can. You can just either walk up to them or call them up and say, 4 times 5. And they'll go, and you'll be able to tell, are they figuring it out or did they just go, boom, 20, drop the pencil and walk back to their desk? So you're going to just basically talk to them. And if you interview them, and if they do it and you're not sure, like, how'd you know? And they say, well, they'll tell you. And these are the choices. Did you count? Did you use a strategy, or did you just know? And then you know if they're fluent, right? There are foundational fact records that you can use. You could just have them all listed out. I love checklists. I don't know if you guys feel the same way about them, but just boom, 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 boom as you're observing the kids. Or having those quick little interviews. There's fluency rubrics included in there. Show them to the kids. Where do you think you are? You have 4? You have 3? Or we really got some work to do. Math journals, great way to assess fluency. Asking them ask the kids, like, what are the easy facts and what are the hard facts? You're going to know right away which ones are fluent on. If they tell you this 7 times 8 one's driving them bananas, then you know that that's not fluent fact for them, right? So lots of talking. Math should be lots of talking.
Good morning. I'm Shauna George. I teach grade 3, 4, 5 split in Laura Burton School. I've been doing number talks for a few years, but I can honestly say probably the last year I've learned a little bit more about what it can be instead of the basic just adding and subtracting and how we talk about mental math. And learning the kids' perspective. The way kids do math now is totally different than I was taught, and probably the majority of you. We were black and white, let's add and subtract up and down. We use pen and paper. We don't think in our brains how things work. So to listen to the kids really gives me a different perspective on how I need to teach them, because they teach me first. And misconceptions is a huge part of it. And you have to understand that they have to be safe, and you have to let them be wrong, and let other kids let them be wrong. And then hopefully they come around to, uh-oh, I did make a mistake. And can we learn from that? So the way I use number talks in my classroom, I kind of have a schedule. I do something different every day. I start with Mad Minute Mondays, but we don't use minutes. I give them 5 or 6 minutes. We started with a whole round and worked our way down because of that anxiety thing. Because I have 3 grades and different levels, they all do different things and different amount of questions to take that. Then I do Number Talk Tuesdays. I do Seesaw Wednesdays. And Thursdays are Number of the Day Thursdays, and then Fridays are my free Fridays, which we do lots of these different math games. We put the technology away, sorry to tell you, but we put the technology away, and I pull out the old board games. We do lots of card games and stuff, just to build that culture and collaboration. So number talks are really about kids learning from each other and not from me, and me getting a better understanding of how they think. We do see lots of misconceptions, and we see lots of different opinions and ideas, but we have to make sure that everyone gets a say. No one gets to say, you're wrong, you're wrong, you're wrong. Squash that right off the crack, because that is not acceptable. I even had to do that with Mr. Hom last week when he was watching me, because he was like, oh, they're wrong. He's sitting in the back, and he's just vibrating. Anyways, you have to know where your kids are at too. Some of my kids would still be more comfortable with a whiteboard. The harder questions you get, sometimes they do need to write it down just to visualize, because they can't do that in their brain. And I really try and integrate my ELA reading strategies in there as much as I can, just that cross-curricular thinking and visualizing. So I tried to give you just as many examples as I could to see what you could use. So lots of these, depending on what you're looking at. You can do area. This is where I started right here. This is the old-fashioned number talks, adding 2 digits together. What does it look like, and how do you think? Everyone adds differently, subtracts differently. 2 truths and a lie. I'll tell you a little story about that, because the first time I did it, I actually made 3 truths, and the kids were like, you lied to us! And I said, that was the lie, is what I told them at the time, but I was like, whoops. So we all make mistakes. So different things, the kids love it, and like I said, they all see different things. And especially when you have so many different grade levels and different abilities, it's interesting to see. You take something like the donuts. I mean, some kids are still adding, some kids are looking for patterns, some kids are doing multiplication and division. So it depends on what you're looking at. So September 12th and 13th, I believe it was, Sherry Parrish, who is the author of the original Number Talks books, was in Saskatoon. I didn't go to the first day because I'd done the basic number talks before. The second day was about fractions, decimals, and percents. That's her new book that came out. So these are just some examples of what she did with us. Really, this is right out of her textbook that she put up there. I just took pictures of it. But different ways for you to see how she dealt with fractions and different things and visualization, talking about area and number lines and stuff like that. So just a different concept. I mean, really, if you are stuck, grab a piece of your textbook and put it up on your whiteboard. And I mean, that's what it is. I mean, start with what you know and what the kids know. That's what that connect is in the front of your Math Makes Sense, really. Okay, so these are some pictures from my classroom. I just took some snapshots of my smartboard, what this mess looks like. This was the last thing we've done as kind of a cross-curricular activity. We did an array city, so actually this is actually filled in as of yesterday, but some of my kids took a little longer, so we did that in art as well as math. So haven't actually done the number talk that goes with that, but they're all different arrays that go with this. This is one of the original ones we did at our first math PD in November, maybe. And it was funny because I did it with the staff first, and then I did it with my kids. And the difference between what adults see and what kids see is amazing. And what they'll pick up, because they really try and one-up each other when they get comfortable. They're trying to find things like, I had one kid say, and I didn't write it down, but he looked at the pattern of the picnic tablecloth behind. Oh. So, you know, what they see and what you might not see, right? And one thing I do have the kids do, and I realize this myself, because when I always stand over here and write, usually, I don't see things the same head on. So make your kids move around the classroom. Make them sit in different spots. Make them lay on the floor, because you see things in different perspectives. Yesterday, actually, we did a number talk, and I counted the numbers wrong. And you'll see that slide, because I practiced on them yesterday. And they're like, Mrs. George, there's 8 in that row, not 7. Okay. Anyways, so these are the key points. Make sure it's safe. Don't let kids chirp at each other, because as soon as someone chirps and you don't squash it, they're not going to share. I start with my weakest students because they can be successful. If you've got a harder question, and my little Taylor in the front row, if he's got his hand up, he's getting it first to make him successful. Record what they're thinking, and this is a hard part, and this is what we practiced and practice and practice at number talks, is that we automatically will write down what we think they're saying, but that's not what they're saying. You have to write down what they're thinking, so you got to be very specific, which was when you showed can you just go back to that one slide? This is why it's all written up, because I was trying to write which cubes they were counting in which order. And so that's why there's blue, because he counted these 2 blues and then these 2 blues and then went around here, and it was a mess. But anyways, so that's kind of key as to how you know. And like, this is my thinking. Well, this is mental math, but to him it was, right? So we can go back to that one. And like I said, accept the answers, wait. Most kids, if you give them a minute, then they'll all of a sudden say, oh, I was wrong. Can I go back and change? For sure. And then talk at the end. What do you see? Is there an easier way? Is there something you might try next time? Did you learn something? Do you know? Give them that debrief to see. And I'll tell you, majority of the time I've learned something different that I didn't think. Okay, so I got a couple practice ones here. We'll just start with this and see where we get to. This is one I've been doing with the kids just because, like I said, I've got 3, 4, 5, and they're all over the board. This gives my little Taylor a chance to do something that he knows, and my grade 5 kids that are now doing division, they each have a chance to be successful. So let's do it together. What do you see up there? What can you tell me? Can we hit that target of 36? Tell me how. Yes, Melissa?
6 times 6 is 36.
Okay. Something different.
2 times 18.
2 times 18. 30 plus 6. 3 times 12. And then I might say, is there another strategy we can look at? We've got our multiplication facts down pretty good. Is there combinations we can make?
2 plus 8 plus 12 plus 14.
Woo! There you go. 2 plus 8 plus 12 plus 14. Okay? 8 times 3 plus 12. Then I might say, okay, order of operations. Do we have to change anything about that? Or does it make sense that way? My kids aren't quite there yet, but you might. Can we start with a bigger number and work down? 46 minus 10. And this is when some kid's going to go, there's no 46 up there. And you're going to say, oh, but we combine those numbers to make it work, to make it accessible to them. Okay, you want to flip to the next one? So that's just an easy one. Now this is the one that I practiced on Friday with my staff, and then I practiced yesterday with the kids. And I was just telling Heather, nothing was the same between the staff and the kids, not one thing. So what can you tell me about these counters? It actually was amazing. So what can you tell me about those counters? It's a pattern. What kind of pattern?
2 blues and 3 yellows.
2 blues, 3 yellows. Okay, can you say that again? 2 times
4 and 3 plus 3 times 4.
2 times 4 plus 3 times 4, is that what you said? And then I might say, okay, can you explain that to me? Come up to the board, tell me how you got to that, because I'm not sure where your thinking is going. Okay, what else? And your kids are going to see different things at what stage they're at, right? If your kids are doing patterning, that's all they're going to see is patterns. If you are in grade 5, 6, 7 and you're taking fractions right now or ratios, what might you say? 2 to 3. 5 groups of 4. Ooh, that doesn't work. 2/5 and 3/5. One of my boys said yesterday, well, that's an array. And of course, this is when I was standing over here. And he said, it's 24 minus 4. And then I was like, what and then I was like this. Well, he had filled in the array right here, made the whole array, and subtracted 4. I was like, yay, success. So just little things like that. You know, give the kids an opportunity to teach you, because I don't think like that, but I'm trying. I'm trying every day to think like them. So that's it.
Okay, so my name's Brianne Denning. I teach 7th and 12 math in Beachy School. Unlike Shauna, I've been doing number talks for a hot minute. Since our last PD, basically, when we just had our Pebble Mentors, I decided to start with my 7, 8, 9s and see how it goes. So the things that I've kind of learned from it and what to do with it is, it's a great start to the class. I find with the 7, 8, 9s, it's, Miss Denning, what are we doing in math class? What are we doing tomorrow? What did you do on the weekend? Question, question, question. It's a lot to get them started. So to do it right at the beginning, they know to sit down and get going. A really important part of it is you don't raise your hand for a number talk. It's all about you have a fist here, and it's how many strategies. So if you found one way, 2 ways, and then you keep going, which was great for middle years where they're competing and want to be the quickest and the fastest and how many. There's no talking. No kid knows who's figured it out already or who has more strategies. Only I can tell. And I can give them all more than enough time to come up with at least one strategy, and then let even the weaker students answer a question. Other things I've kind of figured is for 7, 8, 9, it is a struggle with straight operations to find things that are kind of difficult enough or what it is that you're doing, but there's great ones if you Google it, which one doesn't fit. And there's all 4 of them don't fit in one way. So there's endless different answers that way. And then another way to kind of add more to it middle years wise is, okay, you've come up with it now, what outcome could you attach that to? What is it that we have to learn this year that fits in? And that just kind of keeps them thinking in a middle years direction and kind of adds to it some more. Was there anything else that I found? I also found that they're really needed middle years wise. Just the verbally explaining yourself is kind of a lost skill once you get to middle years in high school. You kind of get on that track of, okay, this is what I need to get done. I just want to sit there, do my work, and get it done. And you try to get them to explain, and you get, I don't know, I just did it, or I put it in my calculator. And so it's a great way, without them even knowing that, they're relearning or practicing how to actually explain their thinking and their math again. So I found them quite good so far. Like I said, I've only been doing them for not even a month, but we're continuing to do it, and it'll be great to see after the end of the year how far they've come with them.